The last thing in terms of electron configurations is recognizing that we can write the electron configuration for neutral atoms, which we've been practicing, but we can also write it for ions. So after an atom has gained or lost electrons, it becomes a charged ion. The ion has a different number of electrons than the atom. So when we write that electron configuration, we have to write it based upon how many electrons there are in the ion. So for many of our elements, especially our main group elements, the ones in the S and the P block, that electron configuration for the stable ion is going to be the same as a noble gas. Sodium loses one electron and then has the same electron configuration as neon. Barium loses two to become like xenon. Selenium gains two to become like krypton. So very often with an ion, it ends up being the same as the noble gases, but it is important to think about what is the symbol you have. So maybe if it was phosphorus, like we had just done, phosphorus does have those 15 electrons, but if it showed it as phosphorus -3, that is 3 extra electrons, which is why we would write 18 electrons in that electron configuration. Or ions, you can still use noble gas notation, but it is important that you wouldn't just write phosphorus as argon in brackets. Although that's true, we still do go to the element that comes before it, neon, and then show all the electrons that it has. That's not as common of a question or thing that you're asked to do, but it is important to note. What is a little bit different is what happens with our transition metals and even a few of these metals right here, tin and lead, that aren't in the transition section, but fall over here in the P block. So when we are losing electrons, we're doing so based upon weak attraction for those electrons, meaning that it doesn't take much energy to remove them. We will connect that with PES in the next video and later with periodic trends and ionization energy. But when we are doing this, they are losing those electrons most easy to lose, the highest energy level. So that doesn't necessarily mean the last sublevel that I put one in. So if I was looking at scandium, for example, the last place an electron went in was the 3D. There's a very long, kind of complicated and somewhat debated explanation as to why this happens. It's way beyond what we need to know. But what we need to know is when we're losing electrons, it is not from the last place, it is from the level that is the highest. So scandium has electrons in level 1, we don't touch those. 2, we don't touch those. The 3s, the 3p, we don't touch. But the 3d are still a part of level 3. Yes, they filled after the 4s, but after they are filled, there's a rearrangement, there's a lot going on, and we think those are still level 3 electrons. So it's the level 4 electrons that are truly the valence electrons. So when we're looking at this, it is the highest level, not highest sublevel. So the electrons from, quote, that row in the S and P block. For transition metals, except for a few exceptions, which we would talk about but not need to memorize, that means because the D block and even the inner transition metals with the F block comes right after the S sublevel, we would say that most, transition metals have 2 valence electrons, the S electrons from that highest level. And we'll see that there's a pattern that means that almost all of them are able to form a +2 ion in addition to any other ions that they can also fill. So as we're thinking about valence electrons, we can count across the periodic table without needing to draw out the electron configuration every time. The alkali metals have 1, the alkaline earth metals have 2, and we consider the transition metals, with few exceptions, to have 2 as well before we go on to 3, 4, 5, 6, 7, 8, with obviously helium being a little bit of a troublesome one, where in an electron sense, we think of it over there next to hydrogen above beryllium. So a lot of the same stuff over these past few videos, practicing those skills, but that's the kind of thing we want to have really well ingrained. So when they appear in that multiple choice or free response, those are automatic points that we can get through very quickly.